if you want to get in touch with me, here's just some quick contact info. So my email, Toby Shnaars at 3DS. I'm on Twitter. I'm on LinkedIn. And I also hang out on the mean streets of Reddit. So if anybody wants to hang out in there with me anytime, there is a SolidWorks subreddit where we get to answer questions and kind of see what's going on in the world of SolidWorks. Also on YouTube. So if you want to get in touch with me on YouTube, I use that same moniker of SolidWorks Toby. I've got a lot of content that I posted on there. So if you like my style of presenting, you might want to check out some of these other videos. My main channel is SolidWorks Toby, but because I worked for the resellers over the years, you can also find me at Prism Engineering. This was actually a song here that I wrote about SolidWorks, about sketching in SolidWorks. So the SolidWorks sketching song. So if you search for SolidWorks sketching song, you'll certainly find that video, and it just reminds people how important it is to fully define your sketches every time. This is another video series that I put up on large assemblies. I know you guys do a lot of work with assemblies here. So if you wanted to, it's almost like a class. It's 168 minutes long total, the video series, but it's several videos that are stitched together to get to that length. But it's all about what you can do with your assemblies if they're not giving you optimal performance. If you open up an assembly, it's running really slow. Here's some tips and tricks you can use to make those assemblies. Yes, a very common problem amongst SolidWorks users. So you can just, if you YouTube search Toby SolidWorks tips, you're certainly going to find my content. And if you need to find any more, just reach out to me. And of course, when it comes to the SolidWorks software, there have been some changes over the years that I just wanted to mention here. You know, back in 2012, we tried to take our customers through the entire machining manufacturing process, design manufacturing process. So this is what we offered in the world of SolidWorks. But over the years, we added packages here. So we started out, or not started out, but in 2012, this is all we really had. And from here, you can see that in 2013, we added the SolidWorks electrical package. So if you're doing electrical design, ECAD, it's a true 2D ECAD package, but it also integrates with our 3D package. We offer plastic simulation as part of that simulation family. So if you're doing mold design and you need to simulate the parts being injected. We offer in 2014 our first product on the platform, on the 3D Experience platform, which was this mechanical conceptual software. And I'm going to talk more about the 3D Experience platform in just a moment. But we also introduced SolidWorks Inspection for what we do when we get our parts back from the manufacturing process. In 2016, we added another package to the 3D Experience platform, and we also added MBD in 2015. 2016, you can see we added PCB to the electrical family. We added high quality rendering to the collaboration family. And in 2018, we added a higher level of PDM management called SolidWorks Manage. Did you guys go to any of those sessions when you were at SolidWorks World? SolidWorks Manage for the higher end project management. So it's something that exists above PDM to manage different PDM projects. So Gantt charts, organization charts, just general project management with specific focus and integration with PDM. It's called SolidWorks Manage. Okay, cool. Yeah, so I'd be interested to hear his feedback on that. And then we also partnered with a SolidWorks Gold partner called CamWorks, and we integrated SolidWorks Cam into every package of SolidWorks as well. So that's kind of the evolution as far as incorporating the add-ins. And then just a couple other little changes that happened over the years were that products were moved from the premium package down into the lower packages. So you can see here when we went to 2015, CircuitWorks was moved down. We added some functionality to the premium package that only exists in the premium package. 2016, kind of the same trend. All these utilities and FeatureWorks tools were moved from SolidWorks Professional. They actually used to be part of SolidWorks Office down into the regular SolidWorks Standard. Hello, welcome. And then 2017, we added some great tools for working with other CAD products. So if you're working with 2017 or especially 2018, which I understand you guys are using, you want to make sure you get familiar with this tool, 3D Interconnect. That's the tool that lets you open up the files from their native format directly into SolidWorks without translating them. So files open more quickly, and they actually retain some of their intelligent design from the native package. So you guys do work with other CAD packages here, right? Like, okay. So that's definitely one you want to get familiar with. If you're not familiar with it, if you email me, I can send you some more information on that. Okay, and the last part of this little quick introduction is just this idea of the 3D Experience platform. You're going to hear a lot about it. So I just wanted to take 1 minute, kind of quick high-level overview. So the 3D Experience platform is a web portal you log into with a username and a password. Your company purchases it as a tenant, and then everyone from the company can log into it. And once you log into this platform, you're going to have access to these different apps over here. So you have this compass up top. It's got 4 quadrants. And from each of those quadrants, you get to different apps. And the quadrants are divided into different disciplines. Like the left quadrant is for 3D mechanical engineering applications. So the apps down below are things like XDesign or XForm, XShape. These are all different 3D modeling packages that run right inside your web browser. This is another project management type of an application. This is what we call our dashboards for doing project management on the platform. This is just like a social feed. Different members of the team can contribute tips and tricks and give feedback to one another, all in the vein of project management. So the takeaway here is that the 3D Experience platform has been kind of a dream of the Dassault systems for going on 10 years now, and it's really coming to the forefront now. If you were at SolidWorks World, you know that you heard a lot about it, and they're actually renaming SolidWorks World next year to 3D Experience World. So it definitely definitely sticks to this theme of they want everyone to know the 3D Experience platform is a potential solution. And ultimately, I mean, these are different brands, some of the different brands that Dassault Systems owns, and each of these brands has 50 to 100 apps that are on the platform. So if you ever run into a spot where you're wondering, hey, wouldn't it be nice if this app existed for the manufacturing process, we might offer it. All right, any questions there before we move on?
The surface flattening, that's a new feature?
Sure, yep.
I had to use like Rhino or something like that in order to get flatten surfaces.
Okay.
So I'm really excited to see that.
Yeah, it's part of Premium. It was added a couple of years ago. It's included in SolidWorks Premium, and it works very similar to the way that a let's say sheet metal application. That's probably the best parallel that we could draw from that. So if, for example, we had a sheet metal component here that we wanted to open. Oh, actually, you know what? I have this in. It's already up saved to 2019. So let me just open up 19 real quick here. I'm going to do the presentation today in 18 because I know you guys are using 2018, so I think it'll make it a little more intuitive to go through some of the steps I'm going to show. So this model here, this is actually a model that came around due to tech support, and it's a sheet metal flattening challenge. And basically, the customer said, "I know we can make this. We're making it today out on the shop floor, but I can't flatten it in sheet metal because I have this bend on a bend here." So with the surface flatten command, what you do is you go to your surfacing toolbar, you choose surface flatten, you choose the faces that you need to flatten, and then you choose the location where you want to hold the surface. So I'm just going to say I want to hold the surface here on this point. And then SolidWorks meshes that face and then unflattens the geometry and then gives you a deformation plot of that new surface. So if we go here to deformation plot, you can see how much stretch versus how much compression needs to take place in order to flatten that surface. You can also project curves onto that surface to act as rip locations. So for bend relief, you can actually just project curves onto it. So if I was going to do this entire model, what I would do is I would go here to surface flatten. And because it's designed to be sheet metal, all the faces are tangent. So I can just do a select tangency there. And then I would say I want to hold maybe this edge here. Now the whole face is going to be meshed, and you can see that the size of the mesh triangles really isn't appropriate for these slotted holes here. So even in the preview of the flattened geometry, you can see these became rectangular. So there's a mesh density here that you can drive up, and that's going to decrease the size of the triangles, and it's going to give you a better flattened result. So if this was a sheet metal application, if we needed to flatten this thing into sheet metal, what we would end up doing is we would end up doing maybe a body delete command for one configuration. So we've got one configuration that's showing in the formed state, and then in the other configuration, we would go insert features, delete body. We delete the solid body here, and then we perform a thicken command here at whatever the wall thickness was of that model. So you'd have one configuration in the flat, and you'd have one configuration in the form. So this is a great way to get around those kinds of sheet metal challenges where it's like, I know we can flatten it. Like, I know we can do it. You'd still have to maybe manually draw in the bend lines if you wanted them in there. It's not going to do that because it's not an actual sheet metal application. But it is a real good command to know about, and it's called surface flatten right here on the surfacing toolbar. Oh, sure. My pleasure. Yeah, and if you guys have any questions along the way, I'm happy to answer those questions. All right, so I just wanted to take a few minutes here. I don't know if we're going to take the full, it's probably closer to about 15 minutes rather than 25 because I want to make sure we get to MBD right at 1:30. But I just wanted to talk a little bit about kind of some quick tips and tricks that I think will help you as you're going through the software. And the way that I construct this presentation is I just kind of go through and show some of the things that I do when I'm getting the software set up. Some of these things are little things, like I'll hit in this little push pin here just to keep that menu showing. Most people probably know about that, probably have done that so that your pull down menus remain shown there. Turn off all your add-ins, right? Because that's going to make SolidWorks take longer to launch. It might make certain applications take longer to run. Like SolidWorks Cam, if you've got SolidWorks Cam turned on, every time you make a change to your geometry, it might try to update the toolpaths, depending on what you've done to the model so far. And you don't want to have to sit there and wait for that. But some of these things are a little bit more nuanced and you might not be familiar with them, especially if you've been working with the software for a while and migrated from earlier versions. And some of those things are things like Instant 2D and Instant 3D. So when you're working in SolidWorks and you're in sketch mode, you've got these icons over here on the end of the sketch toolbar called Instant 2D and Shaded Sketch Contours. So this shaded sketch contours, what this does is whenever you fill in your geometry, so whenever I create some type of sketch geometry here, and then I close this off, the geometry becomes shaded, right? And the benefit of this is that it kind of moves like an instant block. Like I can grab in here and drag to move this around. But the downside is that you can't do drag commands for sketch relationships. So for example, a lot of times if I'm going to add perpendicular or equal or something like that, what I'll do is I'll do a crossing select here, and then I'll go up to the command that I want to add, the relationship I want to add. I'm not going to be able to do that if I've got this shaded sketch contour on here. So it's just an icon right up here on your sketch toolbar. Maybe you knew about it. If you didn't, now you know what it does. All right, another one is Instant 2D. So what Instant 2D does is this is where our dimensions changed from being a modify spin box to being this. This is something that comes up for a lot of users who are migrating into the newer versions of the software. You guys familiar with this? Okay, so with Instant 2D on, it's a little bit maybe awkward to change the dimensions, or especially to delete the dimensions, right? You go delete and you press enter and it doesn't go away. And you're like, wait, I just want to get rid of that dimension. Like, how come I can't delete it? And so if you turn that off, then you won't get that behavior. It'll behave more the way it did in the old days. You double click on the dimension and you can see that then the modify spin box comes up. Cool. So why did they add Instant 2D? Well, it's kind of a derivative of Instant 3D, which is a function that lets you click on a 3D model and grab a face and drag it around. But it also lets you single click on a dimension and change the dimension value. Single click on a dimension here and it just immediately updates. It doesn't require a rebuild for it to update. So they were thinking, well, we want to have kind of a uniform or a consistent interface between feature mode and sketch mode. And that's what Instant 3D does as well. It does what I just showed you there. If it's on, when you click on something, all the dimensions show up. If it's off, behaves a little bit more traditional. So Instant 2D and Instant 3D, good ones to know about. How about the S key? How many of you guys use the S key in SolidWorks? Anybody? Not really? Okay. Well, this will be a good one then. This will be a good one for you to learn about. So what the S key is in SolidWorks is you just press S on your keyboard and this little menu shows up. And anywhere you move your mouse, that menu shows up. So if I move over here, you see it shows up. If I move over here, you see it shows up. If I'm in feature mode and I press the S key, it's a different menu. If I'm in drawings mode, it's a different menu. If I'm in assembly mode, it's a different menu. So this is a great time saver to learn about in SolidWorks. You can see here, if I press the S key in sketch mode, I can right mouse button and I can choose customize. So usually the way that I customize mine is I do this. I get rid of the line command here because this is a flyout menu. It's got line and center line and midpoint line. And I get rid of the rectangle command for the same reason. It's got all the different rectangles and I don't use all of them that often. So then I go down to my sketching commands. And from my sketching commands, I take the regular line command and I add it on there. I take the corner rectangle command, I take the center rectangle command, and I take the center line command and I add them all on there. And then the last thing I do is, even though this is the sketching shortcut bar, I go to my feature commands. So I go down here to features and I add boss extrude and cut extrude. So now my workflow starts to look something like this. Let me just show this again. So I'm going to hit this face, begin a sketch. I'm going to press the S key. I'm going to pick the circle command, press the S key. I'm going to do an extrude cut. Then I'm going to just go through all with that extrude cut. I never had to go over here. I never had to go up here. Never had to go anywhere else for any other commands. Just learning how to leverage that S key. Now, there's another command that's similar to that. It's what's known as mouse gestures. So mouse gestures are a different way of kind of getting to the same functionality. The way that mouse gestures work is you do a right mouse button and drag, and it brings up this little shortcut bar. And some people really like mouse gestures. Honestly, it's not my cup of tea. But it's fine if you like that. And you can see you can go here to customize mouse gestures, and you can choose to add 2 gestures up to 12 gestures. And this can all be customized as well. So the workflow for mouse gestures, if I go back to the 4 gestures here, is you don't typically, right mouse button and drag and look at this menu. You just kind of remember what is where. So for example, if I wanted to draw a line, I would just right mouse button, drag over. If I want to draw a circle, just right mouse button, drag up. If I wanted to do a smart dimension, drag up here and then jump into the smart dimension command. Cool? All right, cool. So a couple other things that you can do here. Hello. A couple other things you can do here are things like modifying this context bar. These are just like real good things you should know about. For example, the S key is just a parking spot for commands that you're using a lot on that particular project. For example, if I'm doing a lot of sheet metal design in SolidWorks, I might go here to my menu for the S key and go to customize and then add some sheet metal commands to here just for that project. And then when I'm done, maybe I'll take them off. Right? It's really easy to customize both adding and removing commands, and that can make your projects go a lot faster. Similarly, when you're in the regular what's called context toolbar, so for example, if I make this construction and then I window select these, this little bar shows up here, this little context bar, you can right mouse button and customize this as well. So one thing I always thought should be on there is the sketch command for sketch mirror. I don't know why it doesn't show up on there. I think it should. Well, I can just go in and add it on my own. So I'm going to add the sketch command for sketch mirror. So now whenever I do a crossing select over a center line, I can jump right into a mirror command. So it's just an example of how you can modify the software a little bit. I don't go crazy when I'm modifying the software. I just take a few minutes to modify it. Another one here that is kind of a hidden gem, it's been in the software for a long time, is the auto dimension in sketches command. And what you do is you go to your options, you go to your sketch commands, and then you enable both of these options down here. You enable on-screen numeric input and create dimension only when a value is entered. And what this does is, as I'm sketching, so if I go to my rectangle command here, these little dimensions show up on the side, and I can type in the values that I want, and now that geometry is ready to go for the next step. Now I can go S key, extrude cut, and then what I like to do is right mouse button through all, and then right mouse button again. So it's all these little cool workflows that you can start to learn that can really save you a lot of time with that S key circle, and then being able to add in the dimension. So I just let go of the mouse and then I add in the dimension that I want. That one is a huge time saver and one that you can imagine I use all the time. How many people are using this one currently? Anybody using this one? Okay. So this lower qualifier here for create dimension only when a value is entered, that's a really important qualifier. You want to make sure that that's on as well, because what that means is that if I come in here and I sketch a line and I type in a value, it gets a dimension added. If I make another one and I don't type in a value, no dimension is added. So that'll help prevent you from over defining the sketch with too many dimensions. It only adds in a dimension when a value is entered. And the other thing you want to remember there is you want to let go of your mouse and then go over to the 10 key, because if you're mousing while you're doing this, you're going to end up messing up the number. See that? So you let go of your mouse, go over to the 10 key. Okay, and then just a quick bonus here, extrude up to next and right mouse end conditions. You've already seen me use the right mouse end conditions a couple of times, but the extrude up to next is another really good one to know about. So the way that this works is that if I begin a sketch here and I go to a circle command, say I make that 1/2 inch in diameter, and then I go to an extrude command, the default end condition that SolidWorks gives us, so that's this area over here, the end condition is blind. That's what you end up with when you do an extrude command. Well, if you double click on a surface, it automatically becomes up to surface. So I go extrude, double click, right mouse button to finish. So it's I'm here, I'm in the SKI extrude. I just double click, that changes the end condition up to surface, and now the mouse is telling me if you right click, that's the same as doing a green check mark. So I just green check mark to finish that one off. So that's another really good one to save yourself having to keep going back and forth, back and forth. So, okay, good, yeah. This is just one that you should know about if you've been using the software for a long time. You can go into system options, you can go into colors, and you can change it back to the classic colors. The reason that I like this is because, you heading out, Monty? Thank you so much for seeing me in. Yeah, great to see you in person again. So the reason that this one is, the reason I like this one is because this way your sketches are blue and your features are green. And your sheet metal is orange and your surfaces are orange. Like it mixes up the colors a little bit, which makes it a little easier to identify the different features in the tray. So you just go to options, system options, colors, and you can change that if you want. You can leave it blue and white if you want to. Okay, winding down here on, I think this is the final tip, assembly edit part settings. So when you're working with an assembly in SolidWorks and you edit a part in the assembly, the default behavior is that everything else becomes transparent. And everything else becomes this transparent and kind of like a wireframe. So you get this, right, when you go to edit a part. So what I like to do is I like to change a couple of options. And these options are found, first of all, in colors. And there's a section of options here called Assembly, Edit Part, and Assembly Non-Edit Part. And so what I like to do is I like to take the assembly edit part and I make it this very first color. It's kind of like a mauve. And I take the assembly non-edit part and I make it the second color here, kind of like a manila. And then what I do is I go down here and I make sure I hit this check mark, use specified colors when editing parts in assemblies. I'm going to hit that check mark as well. And then the final thing is here under display, I'm going to say when I edit a part, don't make all the other parts transparent. Make all the other parts opaque. So now when I go to edit this part, I get this behavior. So it accomplishes a couple of things. It's a lot easier to see the part you're working on, and it's a lot less taxing on your graphics card. So that's the edit part colors when you're in assembly mode. Yeah, the other thing it does is if you ever do convert entities, it makes it a lot easier to pick this face or pick this edge and not end up picking through it. Yeah. Cool, good. And of course, with any of this stuff, if you ever forget or anything, just reach out to me. I'm always happy to, share. Here's what the steps are. The presentation's being recorded, so you can see there's actually several steps you have to do. You go into your colors, you change your assembly edit part, assembly non-edit part, and make sure you hit this check mark, use specified colors. And then you go into the that option under display for edit in context and make it so that the parts go opaque. A couple of final things I do. I mean, I think this is probably more or less common sense, but I always make sure that I have a location for all my libraries. And anytime I'm making something new or custom, like a new material or a new weldment profile or sheet metal gauge table, whatever it is, I'm always adding it to that library. So you can see here's my 2018 library and all the different subcategories I have in there. It just makes it really easy when you're setting up a new computer to point to those libraries. And kind of on that same note, just a final thought here is when you go to commands like insert component new part or import a part from a different file system, you'll be in good shape if you come in here and you specify the template that you want to use when you do that. Not only because then you can predict what's going to happen when you do that import or if you make an insert component new part or a mirror part, but also because you won't get errors. There's certain commands that you'll do that'll throw up an error if you don't have a default template listed in here. Like routing, for example, if you use SolidWorks routing and it goes to make a new routing subassembly and there's not a default template here, it'll throw an error. So it'll just make the overall workflow a little smoother if you take a moment and fill out these default templates, which you can see up here when these default templates will be used. All right. Then you close SolidWorks, because what that does is it writes all those settings to your registry, and then you start up again, you're good to go. Any questions? I think we're pretty much on schedule here. All right, cool. Any questions from the virtual audience? I don't even know how I would receive those questions. Okay. All right, so with that, let's get into SolidWorks MBD. So SolidWorks MBD is a model-based definition, which is a form of PMI. So the general term in the world of manufacturing is PMI, and in SolidWorks, we've coined the term model-based definition. So there's really two key concepts here, and those two key concepts are, number one, we aren't trying to emulate drawings with MBD. So this is a drawing here. It's got everything defined, except for, actually, now that I'm looking at it, I see we're missing a radius on this front corner here. But yeah, right there, see, missing a radius. But everything on this drawing is defined. You can see that we've gone through and we've given the machinist everything that they would need to manufacture this part. We're not trying to emulate that process with MBD. Instead, what we're trying to do is we're trying to replace the drawing process with something that's going to be a little bit better, with something that's going to help you get those projects out the door a little bit faster. So in this case, you can see that not all of the dimensions are there, right? We're not dimensioning the width of that L shape. We're not dimensioning the overall, we're not dimensioning the thinner part of that L shape. We're not dimensioning all those radii. Instead, what we're doing is we're giving the machinist a 3D CAD file, a step file, and we're specifying either in that step file or in some auxiliary file like this 3D PDF, which dimensions are critical. And we're giving the machinist an overall standard beyond that, saying you need to hold your dimensions for this part within, in this case, it's probably plus or minus, for surface finishes, it's plus or minus 0.2 millimeters. I think there's a general note on the isometric view, plus or minus 1 millimeter. Pretty loose tolerance on that one, huh? Plus or minus 1 millimeter, unless otherwise specified. So that's the criteria for the machinist to manufacture the part, give them back to me, and for me to say, yes, these are acceptable and we'll pay you. What we're doing is we're saving the designer the time required to go through and add a dimension to every single edge of the model that you would traditionally see in a drawing. So that's the first key concept when we are talking about PMI and MBD. PMI is product manufacturing information. Yep, and in just a minute, I'm going to have like kind of just a quick overview of some of the terminology we'll be using, so I apologize. But it's MBD, model-based definition, or PMI. What that term means is we're going to include tolerancing information in the model. So we're going to give you, it's a step file. Right now, that's the standard. It's called step 242. We're going to give you the step file, but it doesn't only have the geometry, it also has additional manufacturing information in it, specifically tolerancing and surface finish information. The other key concept is that MBD, inspection, and CAM are all related. So in this presentation, we're going to talk a little bit about inspection, a little bit about CAM, but we're going to mainly focus in the software on talking about MBD. So here's some basic terminology, and the first of that is this product manufacturing information. And product manufacturing information, as we said a moment ago, it means that you're taking a CAD model or 3D model and you're incorporating non-geometric information into it for the manufacturing process. Primarily, that means tolerancing information and surface finish information, but it could also be general notes included right in the PMI. Tolerance, just in case anybody's on the call who's not familiar with tolerance, no parts are manufactured exactly 100% perfect. There's always a little bit of play in the final result that you get when compared to the 3D CAD model. And that tolerance is that play. So when you give a model to a machinist, you say, I need this to be within certain dimensions. I need this to be 3 inches, but if it's 3.1 or if it's 2.9, that's still acceptable. Anything beyond that is outside of tolerance or outside of spec. And tolerance primarily comes in 2 forms, either plus minus tolerancing, which is similar to the example I gave a moment ago, or geometric tolerancing, which would be like power tolerancing, right? If SolidWorks coined it, that's probably what they would call it, power tolerancing. So geometric tolerancing is a more advanced skill that requires some education to learn. There are, classes, semester-long classes, all on GD and T, geometric tolerancing. So that's kind of a quick overview of tolerancing. I'm sure you guys already have had some experience with this, but just in case anybody's not familiar with it. You can see this print here has 2 different forms of tolerancing. It has plus minus and it has geometric tolerancing on it. This symbol down here is a symbol called position. And that position indicates that the center of this hole has to be within spec, within 0.8 millimeters in this case. So it's a position tolerance. It's a form of geometric tolerancing. Relative to what are called datums, which is what that A and that B are. Now, in SolidWorks, we have a tool called DimExpert. You can see that there's a tab here for DimExpert. So we've got a regular feature tree, our properties, our configuration tree, and then this is called our DimExpert tab here, the one with the little crosshair. And what DimExpert does is it lets you recognize different features in the model or on the geometry of the model as geometric entities rather than what they might have been considered in the original feature tree. The other thing that DimExpert lets us do is it lets us apply tolerancing to our model to be used in MBD or to be used as part of PMI. So DimExpert is a tool that we use a lot. It's the foundation of MBD. MBD is really just kind of the set of tools that lets us take that DimExpert information and output it to a format that can be used downstream. MBD is, it's a little misleading with the way that it's named because really the true power behind MBD is learning how to use the DimExpert tool. It's that DimExpert tool that's going to let you set up the foundation, but then what MBD lets you do is then output that to some usable format. Here's an example of the MBD workflow. So you can see on this side of the screen, what we've got is the geometric tolerancing being applied through what tool? Anybody remember what the name of the tool is that we use? DimExpert, exactly. Down here, we create what are called 3D views. And then these 3D views can be output to a 3D PDF. And that can be shared with the manufacturing team so they know what dimensions are critical. When you share this 3D PDF, you also will often share a step file with the manufacturing team. So they've got a 3D model. So I hope that all makes sense. I'm kind of returning to this PMI slide just to kind of wrap everything up with regards to MBD. You know, how does this information all work in the realm of PMI? PMI is the general term that exists in the world. MBD is the specific product that SolidWorks has developed. So, question?
Stupid question. What's 3D PDF?
Great question. Not stupid question at all. So PDF is, you know, the Adobe viewer. It's traditionally 2D. Lots of different files go out in PDF. Everything from a document that you need to sign to a CAD drawing, right? What a 3D PDF is it's a technique that you can use right out of SolidWorks. You can go File, Save As on any 3D CAD model in SolidWorks. And in the Save As command under PDF, it is, there's a check mark here that says Save As 3D PDF. When I save this as a 3D PDF, let's call this 3D. And I had the check mark on for View PDF after complete. What happens is that we can examine this PDF. So we can send this to someone who doesn't have any 3D CAD software, doesn't have e-drawings, doesn't have any viewing tools, and they can examine this assembly in 3D. They need Adobe Reader. Don't get it here, okay. So they need Adobe Reader to view this file, but it's nice because you can send it to people, like I can send it to my mom. I'm like, hey, you want to see this cool CAD model? She's like, no, not at all. I'm like, well, check us out anyway. There's a lot of information kind of embedded in here too. Like you can see the full assembly tree here in this 3D PDF.
Does it highlight?
When you click on the parts, does it highlight?
Oh, it does.
Yeah.
Cool.
Great question. You can, I think you can even play through the views. Like it'll, I forget how to do it in here, but there's a way you can play through the views too, like where it'll show you all the different views. You can.
For reference, did someone say out loud, how do you get Adobe stuff? Through my stuff. Yeah.
Couldn't you also do a 3D view that you add into like PowerPoints?
So there are formats that you can use to do that, like GLTF. I don't know what the other tools are. Have you done that before? Okay, so what's the workflow?
Not for SolidWorks.
Okay, not for SolidWorks. Gotcha. Okay. Yeah, I mean, there are ways to do it as well. Yep, in something like a PowerPoint, if you wanted to rotate it right there. Yep. So that's what a 3D PDF is. So that's what a 3D PDF is, and the SolidWorks MBD software, what it does is it outputs to multiple frames in this 3D PDF format. So for example, I'll show you an example of a 3D PDF here that's been output from MBD. So this is just a simple bracket. You saw this when I was setting things up for the presentation. Earlier in the presentation, I showed a slide with this bracket on it. So the 3D views that we created can be included in this 3D PDF. You're able to rotate the 3D PDF. You're able to click on these different dimensions and have them highlight. Depending on how you defined the dimension, the geometry that the dimension's related to will highlight. You can incorporate notes up here so that other members of the team can actually add notes to this and then save it and send it back to you. So these are all things that you can do with 3D PDF. And this is a big part of what the SolidWorks MBD add-in accomplishes for you, is allowing you to set up these templates the way that work appropriately for the type of project as well as for the department, and also outputting to different frames. Sometimes you have multiple frames. You'll see today as we go through some of the examples, we'll have multiple frames that each have a different view, things like that. Question?
Are you restricted to letter format, or can you go view size?
You can go whatever size you want. Yep, I can show you when we get back into the software. I'll show you the editor, how you can control that. In fact, I'll just show it to you now. So the question was, are you restricted to this size? And the answer is no. There's a true editor in the MBD environment. So here's the MBD toolbar 2018. Here's the 3D PDF template editor. It'll always default you with a an existing template, and then you just take that template and modify it to do what you want. So then you've got your option here for, or not for background, sorry. There's an option in here to change the size of it. Here it is, page setup. So, and then a lot of times what you do with these 3D PDFs is you create, the background can be whatever you want because it's probably not going to be printed. So I have some where the whole background is, like a blue graph paper, something like that to make it a little more exciting than just having everything be white. But you can make whatever you want. You just drop an image in the background. When you create these fields here, these fields can be hooked to custom properties so that when you bring in the file from SolidWorks, these properties here, I didn't have to manually populate these. These are hooked to the custom properties that exist in the part file. So there's a lot of neat stuff that you can do with this 3D, with the MBD output to the 3D PDF. So just some final kind of, like I said, terminology things here. If we're going to be going to a format that is standardized, PMI is not unique to SolidWorks. For example, CamWorks I mentioned before, or MasterCam can read this step 242 and bring the PMI information in from the step 242. So in order for us to be able to utilize this file format across multiple platforms, it had to be standardized, and this is what it became standardized as. So there's basically 3 forms of step now. This is the newest one. Right, exactly. Yep. And the earlier ones, the difference between one and the other, we always get that call in tech support, was one of them would retain face colors and the other one didn't. So it was a pretty minor difference between those two, but this is a pretty significant difference.
242 available in SolidWorks 18 or only?
So the publish out to 242 is dependent on whether you have the MBD add-in. So it's, for example, if you have the MBD add-in and you go down here to 3D views, it's available down here, publish step 242. But if I go file save as, I don't believe it's an option in here. So yeah, we have 203 and 214. Yep. Sure. Yep. Once we're ready to, if we put in, like in this example here, you can see that I've put in some product manufacturing information. So then what I could do is I can go down here and I can either choose this option, which is to create one of those 3D PDFs with the different views and the layout that I showed a moment ago, or I can choose this option here, which is just create a step 242 file. If I choose the first option, which is to create the 3D PDF, there's a check mark that says also embed the step 242 file in with the PDF. So I could just send somebody one file and then they can extract the step file from there. If I choose the other option, it just takes this file and outputs it as step 242, which ends up, I opened up one of these in eDrawings. This is what it ends up looking like. So the dimensions aren't organized into the different views. You kind of just see everything. But if you're doing a machining or an inspection application, it doesn't really matter because the machining application is trying to develop tool paths based on this tolerancing. And then in this example here, you can see that in Adobe, there's a section for attachments. And then here's that step 242 file as an attachment embedded with the 3D PDF. Question?
What does that do to file size?
I don't know. I mean, you're already, let's see, we're already taking it and converting it to step. So if we did this,
I mean, file size of the PDF.
the PDF, we can test that too. Yeah. I'm just curious if this is any different. I mean, it's going to add whatever the step file is. It's not going to compress it or anything. So what?
So you'll just add whatever the file size of the step.
Yeah. Yep.
No fancy compression.
I mean, as a tech guy, I don't want to say because I haven't tested it myself enough, but I can't imagine there's any compression going on there. I've never seen Adobe do that with any other file types that are being attached. Yeah. Non-PMI. It is a lot smaller, huh? Without the PMI. It's interesting. But who knows? I mean, because the file sizes are so small anyway. Like once you get up to the larger file sizes, that's going to be a variable also. I can find that out for you. I don't want you to think that. Okay. Okay. Yeah. Yeah. If anybody has any questions, if I don't know the answer, I'm going to keep track up here on my notepad. Okay. Next, let's talk a little bit about how this PMI, this amazing PMI concept, incorporates with the downstream application. So why should we do this? Well, we should do this because it can save us time when we're generating inspection reports or when we're generating machining tool paths. Those are the two big applications right now. So a coordinate measuring machine, you can see here in the upper right, a picture of it. It's basically a machine. How many people have run one of these before or seen one? Okay. All right, good. Most of you guys have seen one. All right, so a CMM, or if you ever hear that term, CMM or coordinate measuring machine, it's used for inspection. You take your part, you put it on a table, you measure it with a probe. You can automate that as well, kind of similar to tool paths, and use it for inspection, either small runs or long runs. And the results are output to a file which can be consumed by SolidWorks Inspection. So you can take your results from CMM and actually load them right into SolidWorks Inspection to speed up your inspection reports. Now, if you give somebody a print and you're saying all these dimensions are plus minus 5,000, you're not giving them any dimensions, you might have to go for something a little bit more advanced like an inspection optical scanner. So you can see here, this is an example of an inspection optical scanner up here in the upper right, and it's scanning that assembly. And then we're looking at the results there in the post-processing software and whether or not those results are within spec. So in this example, you really wouldn't need any dimensions on the drawings. You would just say, here's the original idealized CAD model. Here's the final part, scan it, and is it correct? A similar example here, you can see this one's more like a chamber. They're putting it in, but same concept. Take the finalized machine part, put it into this scanner, and then compare it to the original idealized CAD model. Is it within spec? And in both these applications, this software can read PMI. So again, the model might be every dimension is plus or minus 0.5 millimeter, except for this, this, and this. And then when you're examining the results, you can see that the results are based on whether or not we're within that spec. Make sense? Pretty cool. I think this stuff is really cool. I think it's like a really exciting way of saving time. Because for the longest time, I would always ask that same question. If we're giving the machinist the model, why do we have to give him a drawing also? You know, and I as I got older, I realized there's a lot more to it than that. But if we can address some of those challenges, like, well, how are you going to inspect the parts? How are they going to know, you know, what the appropriate tool paths are? Then you can get past that, and you don't have to put a dimension on every single edge of the drawing. So the other side of this coin is what's called tolerance-based machining, and this is part of SolidWorks CAM Professional or the higher-end CAMWorks packages. And you've heard me mention this a couple of times already, but in this example, you can see that the tolerance on this pocket is plus 30 minus 10. So you got 40 thou of variance there. The tolerance on this pocket down here is +5 -1, so you got 6 thou of variance. And then the tolerance on this pocket here is +2 -0, so there's only 2 thou. So the machinist is going to have to go in there and manually modify the toolpaths for these pockets that have the tighter tolerance. Well, now they don't have to, because the software, CamWorks, can actually read this PMI and use the PMI to dictate what type of toolpath is going to be utilized in each of those pockets. So these are the time-saving benefits of getting into PMI and utilizing it in downstream applications. And hopefully this will help you ask the right questions when it comes to buying the tools for inspection or buying the tools for machining software. Question?
So since the fine with basic tolerance right now, but can it use GTOL as well and understand the different GTOL symbols?
Short answer is yes. CamWorks can. CamWorks can understand the geotols and it can understand surface finish.
Okay, what about the imaging?
I don't know. Yeah, we're not in that space yet at SO. So I don't know what the capabilities are of that software, but I'll what's your name? Kevin. Okay. I'll write down your name here and find out some different options for optical scanning software. Okay, great question. All right, so with that, let's take a look at the actual software and kind of see what this process looks like. So for this, question.
I noticed that on these 3D views, there are no inspection like circle dimensions. So I'm a bit confused as to, you say it integrates cleanly with the inspection software. How will they know which dimensions to inspect?
Yeah, so it's a similar output process. So you can output from SolidWorks Inspection to a similar file format, like a 3D PDF file format. So this is an example of a model where the customer went, the user went in with DimExpert and did all the geotols and all the different tolerancing. And then the user went in with SolidWorks Inspection and on the 3D model created the inspection report. So you can see all the inspection bubbles here. So then they would either the person doing the inspection would have SolidWorks and they would be able to work right inside of SolidWorks Inspection with SolidWorks, or they would work from a neutral file format like a 3D PDF that has these bubbles and has the inspection report as a separate document.
Okay, I mean, I see them here like 9 and 10, 1, 9 and 10 are actually circle.
Correct, that's what they did here, yep.
So there's that option in DimExpert.
No, in SolidWorks Inspection.
Not the circle balloons, but the oval circle. Looks like those were maybe dimensions.
Oh, yeah, you can do those.
So
Yeah.
those indicate that those need to be inspected, where the others are just tighter tolerance.
Yeah, I got it.
You don't need to inspect it.
Yeah.
You just want the machine to be aware. But in general,
Yep. So the question is, can we add those inspection indicators here in utilizing DimExpert, right? So if I just do, I'm just going to throw a couple of dimensions on this thing. So then if I go to one of these dimensions here, this is a DimExpert dimension, then we can go over here to our dimension properties and indicate that it's an inspection dimension.
kind of what I think. In terms of integrating the inspection process. And then my other question is, it's interesting. It seems that these 3D PDFs are meant to be consumed by humans, and the steps are meant to be consumed by the software. Is that about right?
Yep, that sounds about right.
And so I guess it begs the question, have we really bridged that gap? And what's the point of the 3D PDF at all?
It's a completely valid question.
Another different flavor of PDF, but it's just a PDF, which is kind of like a print, and it's showing some dimensions. It's cool. It's in an isometric view. It's a little bit maybe. Yeah,
so maybe, yeah. So I think maybe rephrasing the question is, is the 3D PDF actually required in the manufacturing process, right? That's the question. So I think my answer to that is it depends on the company. There definitely could be companies that don't use it at all, but if you're subbing out a lot of your work it could be beneficial to the manufacturing team to be able to see the model rotated, zoom in and out, take sections. If they're wondering like what's actually going on here, you can actually section in that 3D PDF. So there's benefits to it. Is it a requirement though? I don't think so.
All that information is captured in the step. So you have SolidWorks, for example.
Yeah, I mean, it is. Yeah. It might be easier to view or easier to use in that step format. You can organize the dimensions into different groupings. In the 3D PDF format, you can organize the dimensions into different groupings. We call them views. So you don't just see a blob of every single dimension. But is it required? Probably not.
Kind of seems like 3D print. It's something you can sketch and maybe.
Yeah.
Okay.
And it's a great question because it really drives home the whole concept of what I introduced in the beginning of the presentation, which is that we're not trying to emulate drawings. We're trying to replace drawings with something better. And what that something is not so much this, it's the step 242, it's the embedded PMI, it's the downstream capabilities of having that embedded PMI.
Okay, so strictly speaking, the inspection cam, they don't interface with the 3D. Yeah, they go off of the step file.
That's correct. Yep, that's correct.
Follow on those questions. You really only, the whole purpose of these PDFs is to show which dimensions are inspection dimensions. And you don't really need to indicate what the inspection dimensions. Those are the only ones that you really care about, right?
You could make that argument, yeah.
I mean, you wouldn't put non-inspection dimensions in the 3D PDF.
I think it's probably a company standard decision. Some companies might do it for clarity. They might show overall dimensions, even though they aren't toleranced. But I think it's fair to say that the biggest reason to use the 3D PDF is for clarity.
Just a point, if you want to call out like a non-global tolerance, that's the place where you have arguably calling it out care about how to be inspected. But they're also, like we do, first article where everything on the print gets measured. Then there's something circle, which is like going forward, you only measure those all subset.
Okay.
So that's sort of like different level of I care about.
So are you currently using SolidWorks Inspection for those first article reports? Okay. So, I mean, that's something else to maybe look into. I don't know if we're going to have time to get into it today.
They always have to mark out the prints with bubbles, depending on which batch it was. They don't line up to one inspection to the next.
Okay.
Associating bubbles like you showed.
Yeah. Yeah. So, I mean, the SolidWorks Inspection, the two big benefits of that are one, really the biggest benefit is just the creation of the report. You don't have to do the bubbling. It just rips through and grabs all the dimensions. Now you can pick and choose which ones you want, and you can eliminate some. But the other one is that it does the min-max calculations for you, which can sometimes be tedious if you're not doing it all the time, especially when it's like a weird tolerance or a weird range. So it does all that min-max calculation for you too. And then there's two levels of it. There's SolidWorks Inspection and Inspection Professional. The SolidWorks Inspection, then when it generates the report, like in Excel, it has the conditional formatting. So then as the inspector goes through and is just punching in numbers from the results, if they land outside the range, it automatically color codes them. And standard stuff for the inspection world, but nice that it's already taken care of for you. And then the Inspection Professional opens up the capability to import the data from a CMM or from even a digital caliper with a USB. You can even pull in information from that directly into the report. So that's the main difference between the standard and the pro. It also, inspection also works with non-SolidWorks files. So you can do the SolidWorks inspection on a PDF, and it does optical character recognition. So it could even be like an old hand drawing, and it'll try to recognize the characters just by doing window select. So you don't have to type it in. So it's something to look into. If we have time today, I can show you a little bit more about it. If not, we could set up like a remote session, or I can get somebody to do a demo for you, send you some good content. What's your name? Mark. Nice to meet you. I'm Toby. Okay. inspection stuff. All right, cool. Great questions. Okay, so just a little overview of how this process works in practice. So it's not dependent on the CAD feature tree. It can be applied to any model, including an imported model. So this first example that we're going to look at here, you can see it doesn't have a feature tray. It's a completely imported model. And so what we do is we turn on the add-in for SolidWorks MBD. We can see it's on here. We go to this fourth tab here, which is the DimExpert tab, and we begin adding in DimExpert information. Now, after I do this the first time, you're going to have a question, which is how do you control what the tolerances are that are being applied? And I'll show you that as well. So we click here where it says auto dimension scheme. We declare what type of part is it. So is it a turned part or a prismatic part? We declare what type of tolerancing we want to use. So geotols or plus minus tolerancing. We declare if there's any pattern information, are they going to be linear patterns or polar patterns? And then we declare what our datums are. So I'm going to say this is going to be my primary, this will be my secondary, and this will be my tertiary down here. And then down at the bottom here, we say we either want to dimension everything or we want to go through and pick and choose what gets these auto dimensions applied. And when we say we want to dimension everything, we can further kind of narrow it down regarding what we actually get dimensioned. I'm going to leave everything on for this first one. I'm going to hit the green check mark, and SolidWorks goes through and applies dimensions to that part relative to those datums. So yeah, you get a big mess. Probably not what you want, but interesting to see. And this is from a model that doesn't have any CAD data in the feature tray. So once we go through and we look at this information again, the question is probably, how is it coming up with this tolerancing scheme? And the answer to that question is found here in document properties under DimExpert or under MBD, depending which release of the software you're working on. So here under DimExpert, you can see that we've got these different tolerances here. Now, before I go any further, I just want to call to your attention that we've got these two tabs here, System Options and Document Properties. And everything on the Document Properties tab is saved when you create a template. So everything on Document Properties is included with the template. So that's important to know when you're going through and you're setting up MBD, because what it means is you can set up a template that has appropriate dimension sizes, and in this case, appropriate tolerancing options. The other thing to just call to your attention is this is also a subset of the drafting standard. So this is another place where once you get it really humming along and working well, you can save off these settings into what's called a drafting standard. So I'm going to go through here and just take a look at these DimExpert things. So you can see for size dimensions, plus minus tolerances, location dimensions, chain dimensions, how are they going to be handled, chain or baseline, some additional options for geometric tolerancing, chamfer options, and final display options for how things are going to be displayed. So this is when you just let it rip, this is what you end up with, these results here. Okay, so far so good. So now let's be a little bit more specific as to what we want dimensioned. So the two ways that we can be a little bit more specific as to what we want dimensioned are we can come in here and use these dimensioning tools. Like I could use a size dimension tool, for example, and pull off a size of this circle here, of the cylinder. Or, so we can just do kind of one at a time and start going through and punching in our values. Or when we go to the auto dimension command, we can just specify certain features that we want to have dimensioned. Oops, clear that. Here you can see I'm using the right mouse button trick again. So I pick that first face, and if I right mouse button, I'm advancing to the next box over here. So you see the mouse kind of changes to a carriage return, just saying advance to the next box. And then I'll go here to selected features, and I'll just go through and pick a few of these. Now, if it's an imported model and they're organized a certain way, DimExpert will automatically recognize them as a pattern. Otherwise, it'll be up to you to make sure that all the appropriate geometry is selected.
If you wanted to override that and say, hey, this pattern.
Can you break it up? I think you can break it up in the tree after. We'll take a look at it. Yeah, a lot of times when you make your selection, also you get this box here, which lets you do things like compound surfaces. Like if I had 2 holes that were in line, but there was a gap pocket in between them, I would use that option there, compound hole. So there's a lot of feedback that you get from this little shortcut bar that pops up. Okay, and SolidWorks goes through and applies dimensions to all of those features. Let's see here. So we get this whole pattern here, right mouse button, and we'll do I thought there was like a uncombine. Like when you multi-select these, there's a combine option. Wonder if I delete this, if it'll just, yeah, I pulled them out, but it got rid of the dimensioning as well. So I would have to go back in and dimension those. And again, the way that we would do that is we could use either a locating dimension or a size dimension. So if we do a locating dimension, we could go from, say, this surface to this cylinder here and, whoops, position that dimension. There we go. Okay, so maybe one final dimension would be from this front surface to this back surface here. Okay. So the first step is you create all the dimensions that you want in the model. The second step is you organize those dimensions into what are called annotation views. So annotation views appear here in the SolidWorks DimExpert tree, and annotation views also appear in the standard SolidWorks tree. Annotation views have actually been around for quite a long time. I remember in probably 2006 or 2007, I gave a webinar to a company on how to use annotation views. They wanted to take advantage of this idea of annotation views. So what that means, what that term means or is referring to is views that you can bring into a drawing and you can automatically bring in the dimensioning information dependent on that view. And that's very similar to what we're going to do with this example. So for example, I've got this front view here, and these dimensions here are all assigned to that front view. If I wanted to move some of these dimensions to a different view, I can. For example, I've got this right view here, and it's just got this one single dimension on it. And I've got this top view here. Let's see what's on this top view. It doesn't have any dimensions on it. So if I wanted to take a dimension and move it to a different view, I can. I can right mouse button. I can say change annotation view. There's also a shortcut for it. You can just press the tilde symbol on your keyboard, and that lets you change which view the annotation is associated with. Now, from here, if I was to make a drawing, when I go to make this drawing, I can bring in one of these views. And here I can say I want to import annotations. And I can say I want to bring in the DimExpert annotations. And so what we'll see here in the view of the tree is that some of these views have a little A on them. And that means that's an annotation view. So when you bring it in, any dimensions that are assigned to that annotation view are going to come in as well. So it was a way of, it was an option that SolidWorks added a few years ago to control which dimensions show up when you bring in a drawing view. So there, those dimensions show up, there, just that dimension shows up. As opposed to letting the software kind of decide what's going to show up in the drawing. You can control it ahead of time. So we can do the same thing when we're creating these 3D views for MBD. We can activate one of these views. I'm going to activate the front view again. I'm going to go down here to my 3D views, and I'm going to say I want to create a new 3D view for MBD. I'll call this one front. And I'm going to repeat that process. I'm going to make another 3D view. I'm going to say this time I want to use the information from the right. Actually, I did this wrong. I didn't capture this correctly. So let me go to the right side view here, activate and reorient. So what that means is that I'm hiding all the dimensions from the front view. So I'm taking this view here and essentially doing a hide. Here's the front view. And I'm only showing the dimensions on the right view. That's what it means when we do that activate and reorient. And then I'm going to recapture this view here, and I'm going to rename it to right.
So, Toby, forgive me. I'd like to what's available with and without MBD. It seems that with these annotation views, the DimExpert's always built into SolidWorks.
Correct.
Always put the dimensions, annotations on your model and associate them with these 2D views, pull them in drawing automatically. Very cool. This 3D views tab at the bottom, the MBD or at the top, that's something you only get when you get the add.
Correct. Yep, great question. That's correct. And so you can see there's actually a lot of overlap here. If I go to DimExpert, this like first grouping of tools is the same as the grouping of tools here on the MBD tab. The biggest thing is this one down here, the export to step. So the step 242 export and the step 242 export when you create the 3D PDF, that's all part of MBD as well. All right, so so the final thing I'll do here maybe is just grab one more view. So I'm going to activate this unassigned items just because I don't have anything in that view. I'm going to jump into an isometric view here, and I'm going to do capture 3D view, and I'll call this one isometric. And you can see that I have some properties included in this part file already. So when I go to publish a 3D PDF, I have this group of templates that I can choose over here, different layouts. We talked about that earlier with the 3D PDF editor. And then I'm going to say which views I want to land in that 3D PDF. If I have anything I want to attach, like an image or any other file type I want to attach and include with this 3D PDF, this is where I can do it with this attached files. And there's a check mark down here that says create and attach step 242. And then what I can do is I can go to the second page here. And on the second page, I can I can click this edit button and I can control my properties. So some of these properties are linked properly and some of them are not. So maybe I just need to go in here and choose the additional ones that, you know, are not, like designed by. I'll hook that to drawn by. Material, if I had a material in there, it would show up, weight, et cetera, et cetera. Okay.
Before you publish, what other files can you attach as references to this?
Anything. Yeah, it's a Windows browse dialog. Whoops, sorry about that. I meant to go back.
Would these references probably be in the PDM as basis reference or solid?
I don't think so because they're embedded in the file. It actually becomes embedded in the PDF. Yeah, so the
So it
PDF.
actually doesn't treat it like a parent child reference.
I can test it. We can test it together. Yeah. So I'll add this turned part as an embedded part in this one, and then we'll check it into the vault and we'll look at it together. Yep, that's a great question. Okay, so now we're gonna hit the green check mark. And we're gonna give this file a name. And we have this view as PDF after. So yeah, it's going through and capturing that information. It always seems like it does it twice, and I'm still a little perplexed by that, but it's going through and capturing that information. This is the Adobe environment here. And yeah, you have to say trust this document when you open this up because of how it's embedded. And there you can see the views were created. The dimensions were included. Now, there's some subtleties to this, you know, with regards to font sizes and things like that we can adjust back in SolidWorks so that they come through as desired. But overall, you can see what the result is here on this 3D PDF.
What about details, like sections, section cuts, and things like that?
Yeah, great question. So I'm gonna make a couple of parts today, but I'll show you the section view in the next one. Yep, it's a great question.
When you rotate that model, all of the, like the one thickness dimension doesn't show up until you select the view where it's not hidden.
Correct. Yep, that's correct. They are all embedded though as objects in the true PDF tree. So there's this 3D PMI actually contains all of the dimensions. So even though they aren't showing up here, there is a way to get them to show up. Yeah. Yep. Okay. Great questions. And you can see here's the two attached files. So let's take this file now and add it to the vault. So we called that one sample part imported. I'm just going to drop this right at the root level. Yeah, it looks like it's just going to go in as a container essentially. Yep. Yep. Great question. All right, cool. So, so let's take a look at another example here, this time in assembly. So you saw I already had this one open. Now, I'm not going to do this one completely from scratch, but what we will do is we will incorporate a section view into this one. So you can see that I've got these 3D views down here. Let me delete these 3D views. That's part of MBD. You can see over here that I've got my DimExpert tab. I've got this thing dimensioned, and in the DimExpert tab, there's these different annotation views. So I've got this front view. I've got this side view, some dimensions on there. I've got a top view, only this one dimension here. And for this one, what I'm going to do is I'm also going to add a BOM to the assembly. So let me make a new annotation view. So I'm going to say create annotation view, and I'll call this one, I don't want to move any. Exploded for BOM. And just make one of the tricks you have to remember is just to hide some of these different annotation views if they're not giving you what you want. Okay, and I'm gonna actually, you know what? Yeah, that's what I wanted. Okay, cool. So then I'm gonna go to my configuration tree here, and I'm gonna add an explode view. So you can see I've already got one. This explode view, there's actually, if you're just doing real quick explode views, there's a really quick, easy trick you can use, which is you go new exploded view, and then you pick this option here, auto space components on drag, and then you just window select everything, and then just grab this arrow and drag it a little bit. And you see all the parts kind of spread out when I did that. Whoops, let me try that again. So I'm just going to delete that and do it again. So we go new exploded view. And what this means is, like, if you had 3 parts and you grab them and drag them, they would space out like nut, bolt, washer, or something like that. But if you do that for an entire assembly, it can be a nice time saver just to get the whole thing to kind of explode. Pretty unlikely, but it's just it's kind of a good starting point. Then you can start pulling the other parts off. All right, so now we've got an exploded view here. And what we can also do here is we can create a bill of materials. So I'm going to go insert tables, bill of materials, and I'm going to use the default options here for the bill of materials and just kind of drop something in here. Oh, that looks really good. Let me just maybe make this font a little bit smaller. Okay, and then what we're going to do is we're going to notice here that the description column is empty for this bill of materials. And we're going to take that bill of materials and we're going to make sure that it gets assigned to the notes area of our annotation views. So we're going to come in here and just take this bill of materials, and we're going to say that we want it to go to the annotation view notes area. And what that does is it makes it really easy for us to hide that bill of materials when we don't want to see it. Okay, so now we've got some views that we're ready to work with. Let's start creating some 3D views. So we'll start out here in just our isometric view, capture 3D view, call this one isometric view, that's fine. We're gonna go to our top view, activate and reorient, maybe zoom in a little bit here, kind of capturing this foot pedal here. We'll do capture 3D view, and we'll call that one top. And we'll go to our front view here. So front, activate and reorient. And, we've got some different dimensions here. If we move this at all, we just want to make sure we, rebuild so it's up to date, and we'll do a capture view here, front. And then we're going to go to our exploded view. And we'll just do an orient, so it goes isometric, and we'll take this explode view here, and we'll say, maybe we should throw some balloons on here. So balloon, I'll say I want this to be hooked to that bill of materials that I created earlier, and then just throw some balloons on some of these parts. Okay, and we'll say capture 3D view, explode view for BOM, that's fine. And then let's go back to our non-exploded view and go back to our regular isometric view here. That is not isometric. And then let's take a section view here and something like that. And we'll say capture 3D view. And we'll call this one section 1. All right, I think it looks pretty good. And now let's bang that out. So basically that's what you do. All you have to do is grab a section view. And the trick here is when you're double clicking through these views, This should be more or less what you get in the 3D PDF. So if you want to test something like, will it remember, like you see right here, the section view tool is not turned on, but then I double click here and then it turns on that tool. So if you want to kind of double check that, that's how you can kind of validate it before you actually.
All sorts of visibility and everything when you create that 3D view.
Yeah, for the most part. I don't know if it does transparency or not. Let's try it. Because there's so many ways to do transparency too. So let's say recapture view here. Let's go to top. It's still transparent. Yeah. Yeah, we'd have to test out the per instance scenarios. Because it could be something where like if you change it in one spot, it keeps it. If you change another spot, it doesn't.
Interesting to this what's persistent and what's not.
Yeah, no, that's good. I'm gonna make a note of that.
Would those views work for different configurations as well?
They do. Yep.
Oh, that makes sense.
Yeah. So that's another good point. So like, let's say we make a configuration here called pedal only, and then in this configuration we suppress everything else. Or we could hide everything else too, but then it gets into display states. Your display states could override or could come into play there. So let's just suppress everything. Okay. Couple of guys hanging out down here. All right, and then we'll go here. And we'll say, actually, let's get normal to that guy. And we'll say capture 3D view. And we'll call this one pedal only. So then if we jump back to this one, now it automatically changed configuration. Changes back and forth between them. So that's like a good, if you're hiding and showing or making changes in other spots and it's not sticking, that's a good surefire way to force it through with consistency. So now we'll do, now we will do a publish, and we go to publish here. I'm going to switch my template here to one that has an actual bill of materials as part of the template. I'm going to say which views I want to include in this process. And I'm going to go down here to this section down here where I can, there's an additional option here for what's called independent viewport. You'll see that in a second when we go to the drawing. Then when I go to page 2 here, I can control what's going on with the bill of materials. So you'll see here, there should be a option here. So what I'm expecting to see here is an option that says what information in the bill of materials do you want to include in the table. Basically, I can uncheck the option for description since description wasn't showing up. I'll have to double check why that's not flying out. I think it's just being funky because it knows I'm demoing. All right. Oh, speaking of being funky, that's good. Okay, let's give that another try. 2 funkies in a row. We don't want that. All right, let's try that again.
While you're starting, I have a question.
Sure.
I think, I'm not certain, I think like when you're in Sketcher or something, there are tolerance options that you can input on Hand Manager. But that's different than a DimExpert dimension.
That's a great question. So,
Get those on the annotation views.
yeah, so it's not really all that different. So for example, this dimension here is a driving dimension. It's from the model. It was created during sketch mode. And you can see what the property manager looks like over here. So you've got things like dimension text, and is it an inspection dimension? Does it have parentheses? What's the precision? All these different options here. Now, if I go to a DimExpert dimension, like this dimension here, you can see this property manager looks very similar, but there are some differences as well because it's referencing those datums or in this case, not the datums, but the reference planes that were created during the dimensioning process. Because when we view this dimension in the 3D PDF, these faces will highlight.
So the information that's captured in that model, the model dimension, tolerances, that, how is that useful? Where does that actually land in?
You're drawing, if you do model, dimensions or model, import model, then dimension model, you can have import annotations or.
So you can use it there, yep, or you can use it in some of the downstream applications like the inspection process or the machining process. That's where it's used. That's where it's the most useful.
And so you don't have to put it on an annotation view to import it. I guess I'm wondering, for example, if you had conflicting tolerances, one in the model and then one in the DimExpert, you got to pull it in to a drawing. Yeah, I guess I'm just.
Yeah, if you showed both dimensions, yeah, it would be problematic. You can go a different route also. You can do a show dimensions command. So for example, wow, this thing's missing some of the parts still. That's not good, huh? Like these guys still came in suppressed. Okay. So for example, if we go into this part here and we start creating, or if we had created these dimensions here in the part file and applied tolerances to these dimensions, you can do show feature dimensions here and then bring these dimensions into your drawing. So there's other ways that you can do this as well, but it doesn't come through for that step 242 PMI tolerancing information. Because when you're defining these dimensions, you're defining them typically to sketch geometry, but when you define the DimExpert information, you're defining it to faces. And that's what's carried through into the downstream applications. So you do have some options, but for the most part, you're going to be using what's in the DimExpert for the MBD and PMI information.
So the whole DimExpert process is rather redundant to the model process. Nice.
Yeah, so it kind of comes back to the age-old SolidWorks design best practices versus machining manufacturing best practices. You know, where's the 000 on the model when you're designing versus where's the 000 when you're machining. So it can be redundant, but a lot of times it's not, because a lot of times you design something different than how you manufacture it. So the DimExpert process is definitely taking more of a machining inspection point of view. You know, you start at one corner, you start at one side, where in SolidWorks, a lot of times you start in the center and work out. It can be, though. I get what you're saying. Yeah. I'll see if I can find any other, like if there's any way to use the actual true model geometry and carry that through into the PMI. Okay, cool. All right, I'm going to give this another try and just see if it's wonky. It makes me a little nervous that when it regenerated, it was missing parts, or like these aren't. I wonder if I should just suppress this whole thing as a subassembly. Maybe that's what the problem was.
I don't think you had properly set up right in configuration.
What was off about it?
When you set your configuration, you can select whether to suppress components and other configurations.
Oh yeah, that option actually, it's a little different. That's an option for what that option should say in the front of it is what should I do if you bring in a new file, if you bring in a new part. So like this option here that says advanced options, hide new components, suppress new components. You should imagine that in front of that it says, what should I do with a new component if you bring it in? I'll suppress it. What should I do with a new component if you bring it in? I'll hide it. So if I'm in a different configuration and I bring in a new component, it'll be suppressed in this configuration or unsuppressed, depending on if that's checked. Yeah, I think that in this case, my mistake was that the beater was part of a subassembly and I suppressed the individual components. And it got a little wonky when I did that. Let's try again. All right, so we got our different views here. And we've got our, see, here's that checklist that I was telling you about that lets us uncheck the option for description because our description fields weren't properly populated. So there's no reason to include them. And then our final fields here, the metadata property coming from the models. Now we're going to watch the part dance around, right? So this one, this layout, this template actually has multiple available views. So you see I can show this one maybe in a isometric, show this one in a section view. So this has got multiple viewports on the same screen. And again, it's just for convenience, just for clarity. You know, why do we have these different viewports? Why do we have the 3D PDF at all? That's why. This listing of the views here, you can see you're able to select through the views. There's also a play button down here at the bottom, so you can just let it play through and examine all the different views that are over there. This is a multi-sheet 3D PDF this time, where the last one that we looked at only had a single sheet. So if we go to sheet 2 here, you can see sheet 2 is where the bill of materials is listed. And then if we go to sheet 3, this is just it's called an independent viewport. So just a larger view of what we're looking at on the earlier sheets. So we can go through here and look at some of the different views.
So we can show any SolidWorks template or table on yeah.
So you put your tables in the notes area. So I know there's a lot of different tables. What table in particular are you interested in?
Like an inspection, like just a general.
So if it was a general table? Okay, that's a great question. Let's see. Oops, I want to save this. All right, wow, 2 for 2. Yeah. All right, so let's go to a different part file here. I'm just going to open up this bracket here. All right, so the bracket doesn't have any PMI on it currently. Let's just put some PMI on here. I'm going to do auto dimension, and I'm going to say I want to dimension this. And these are SolidWorks features, so that's why they're showing up all together like that. So I'm going to say I want to dimension all that information, and I'll pick some additional datums just so that we've got everything defined here. Now, another thing that you can do that's kind of cool is you can turn on this option here in MBD. And what this option does is it lets you know if the geometry has been defined by the DimExpert. So as you define more and more geometry, these faces will continue to become green until everything is defined. So now that we've got that geometry in place there, you can see that what MBD does is it automatically creates these annotation views. So I've automatically got a front view created. I've automatically got a right side view created. I've automatically got a top view created. It just automatically creates those annotation views. But again, you have the flexibility to take those dimensions and dump them into any view that you want. So let's go to the notes area here and insert a table. Actually, I'm going to put this right on the top view because then we can see if it'll show up as part of that view. And we'll call this one Toby and Mark, right? Mark with a C. Got it. All right, cool. All right, so just going to move this out of the way. Or not. Alt, drag. Okay. All right, and so we'll save this and we'll say we want to capture this view as a top view and just the top annotations from that. We'll say we want to activate and reorient the right side view. And we want to capture that view. And maybe we'll grab an isometric view. and just capture that as well. And we're gonna output that. Use this single sheet one again. Control the views that we want to take out. Any other additional options here? All the metadata. Cool. Yeah, great question.
So you can put that table on its own sheet, right?
On its own view or on its own sheet? Like, will it come in
Its own page.
as its own page?
I don't need you to demonstrate.
Yeah, so I think the answer to that would be found here in the template editor.
Just like you did with the file.
Yeah, exactly. So up in the see, we can insert that one, but it's let's see if we've got, let's just kind of see what this looks like on sheet 2. See, I guess that what I don't know, and I'll find out for you, is if that bill of materials template is hard coded into it, or if that's a user option to add that as a table. Because I can't remember ever configuring it, so I kind of feel like it's hard coded in there. But let me dig around a little bit and see if I can find it.
You don't have to have your structure predefined in the template if you want to do interesting things.
Can you add like a fourth page and just
Yeah.
put a generic table on it?
How would you just sort of?
So the generic table is kind of what we're getting from this. Let's see here. Oh, it was that other template that we were working on. So this is like a generic table here.
Gotcha. So you use them with tables.
Yeah.
You can just like add a bomb table to this one as you're saving it out. You need to go into the template and change it so that it pushes into our stuff. Or you can.
Yeah, I mean, you add this, which is the bomb table area.
You're editing the template specifically.
Yeah.
And then presumably you have to save it in order to use it. If you just wanted to one-off, add something, a special view, something like
Probably
that.
just put it on its own view and then just capture that view without the model.
Yeah. Yeah, I mean, there's not a way to on the fly edit the templates. Yeah. Yeah. Yeah, and I think that's the best solution for the generic table. But I'll find out if we can use generic tables the same way we can use bill of materials tables, where like it creates and formats it nicely for us, fits it into that view, you know, all the stuff that it's doing with the bomb table. Cool. Awesome. Great questions. Thank you. This is all good stuff. So, I mean, you kind of see the gist of how this all works. Sometimes you have parts that are maybe a little more complicated where you got to do more manual steps rather than, you know, having it all kind of automated in one shot. For example, if we were going to do just the beater of the subassembly, we might have to manually create some of these dimensions. We might come in here and say, you know, this is a scenario where these two holes are in line with one another. So we might come in here ahead of time and define those using the DimExpert tool feature pattern. And we can take, you know, you can just click here and SolidWorks recognizes that they're coaxial. So it hooks them together as a complex whole. And that way, when we go to dimension this, if I click here to dimension it, it automatically comes up with the 2x for that hole. I'm going to go into my annotations here and say I don't want the text to always display at the same size. Make it a little bit easier to say. Actually, I could probably just keep that at 1:1. We could go to a location dimension and define what the overall length of this thing is. Oh, I did basic location dimension. Let me just do location dimension for this next one. We could say, you know, what the distance is to there. We could say what the distance is to the hole. So you can see you're kind of little by little going through and fully defining this thing. And again, if you turn on this option, you get this feedback indicating what is defined and what's not. We could go to this section of the design. This is a cone here. So when we go to size dimension, you can see that the dimension that we get is an angle dimension. And you can see here that this angle dimension, it's automatically mapping to the top annotation plane. So I can hide some of these other ones here. I'll activate this one and I'll hide some of these other ones. And you can see that that dimension's on the top annotation view. If I click on that dimension and press the tilde, I can move it to the left annotation view. And now you can see I'll activate and reorient here. And then you can see that angle shows up there. So it's really easy to move these around so they end up on the correct views. Now, this is a pretty common spot here where there's a fillet on the end, and maybe we're leaving the fillet up to the discretion of the machinist, but we still need to declare what the diameter is at what would be the sharp edge. So in those spots, we can just come in here and either do size dimension, or we could do location dimension, depending on what the application is. But in this case, it's size dimension. And then I can pick on this face, this planar face, and then click this virtual intersect circle, and then click on this face here, and hit the green check mark, and then SolidWorks creates a virtual circle there at what the intersection would be. So anytime you have like a fillet in a weird location, like two angled faces coming together, there's a fillet there and you want to measure to the sharp, you can use a very similar command, but instead of a circle, it's a line at the intersection of those two surfaces. So, I mean, I think you guys pretty much get the gist of this. You know, the last thing I just wanted to share with you, and I'm not going to show the whole video, but I have this this video here just for illustration of some of the other downstream results. We've got things like the tolerance-based machining that you've heard me talk about a lot throughout the presentation today. I have this muted. I'll just kind of talk over it, but you can see here is a fairly complicated SolidWorks model that has PMI incorporated into it, both dimensionally and surface finish wise. And you can see over here what the SolidWorks feature tree looks like. And in just a moment, we're going to see what the manufacturing tree looks like. Here's just going through and adding in the surface finish information, PMI. And then here we get into the machining application. So this is CamWorks, which is SolidWorks Cam and CamWorks are the same thing. It's we purchased CamWorks and developed SolidWorks Cam. And here you can see that he's using this tolerance-based machining so that instead of all of these, in this case, these little dimples here, or some of these pockets that have different tolerances, they're going to automatically get toolpaths assigned to them that are based on that tolerancing. The machinist doesn't have to go through and program in all those toolpaths manually, just based on the dimensional information. It's actually automating that process of generating those toolpaths. So that's the whole thing with CAM, is that it automates the toolpaths based on the geometry. And this is now taking that one step further, not only based on the geometry, but also based on the tolerancing information. Make sense?
This tolerance-based machine, is it just leave material, clean up material for like in the past or something?
That's what this is. This is tolerance-based machining. Is the toolpaths will be like, you'll use a different size tool. You'll use finer toolpaths. You'll do more passes if there's a tighter surface finish, or if there's a tighter tolerance, automatically. That toolpath is written automatically in that fashion. With the, it's written to grab a different tool. It's written to do more passes. It's written to do finer passes, automatically based on the tolerancing information from PMI. That's tolerance-based machining. Okay, and the other element to this that we've talked about now a few times is just this idea of inspection. Generating inspection reports using CMM data, for example. So this is the SolidWorks inspection environment here. You can see that what's happened here ahead of time is that the SolidWorks drawing has been open, And once the SolidWorks drawing was open, the user went through and captured all the dimensions, either by manually clicking on the dimensions or by just saying grab everything and letting the software go through and grab all the dimensions. And when you have Inspection Professional, you get this check mark for allowing the input from a data package from a CMM result. So that adds this area over here where you're able to import the data from CMM and then actually use that during the inspection process. So the only thing different about this compared to what we've been talking about all day is that instead of looking at a 2D drawing, you'd be looking at a 3D model. But other than that, you'd still be able to import the data from the CMM and then use that information over here in the inspection report to see if you're within spec.
Sorry, is he manually typing that in?
He is at the moment, just to show one way of doing it. So here now he's actually bringing it in from the CMM data. Yep. So there came in over there. And then the only post-processing you have to do is just to make sure that the dimensions were properly captured in the correct order relative to the inspection report. Like item 1, item 2, item 3, item 4. If there's any combination dimensions or anything like that, you have to clean them up. And then if there's more than one, sample set that's used in the inspection process, you can bring in those additional sample sets. And you can see they'll start populating here. And that's the basic gist of, SolidWorks MBD, SolidWorks CAM, and SolidWorks Inspection, and how they're all kind of tied together, right? We do what's called PMI, and we utilize that PMI, which is essentially the product manufacturing information. It's the geometry of the model, but also the tolerancing, geometric tolerancing, and surface finish information. It could also be additional things like notes. You have notes on there as part of the product manufacturing information. We do that in SolidWorks because it allows us to avoid the process of dimensioning every single edge on the drawing the way we would traditionally do it, and instead hand off the model to the machinist with specific dimensions that need to be held to a tighter tolerance, and then a general tolerance for all the other geometry. And not only can it be used by the machining team, but it can also be used by the inspection team in that same kind of downstream flow. It makes sense? So PMI is a generic term that's used throughout the industry, and MBD is the SolidWorks PMI solution. I know it's a lot of like letters and acronyms and things, but hopefully it makes more sense than when you walked in. If you walked in and you're like, what's MBD? What's PMI? Now it makes sense, right? PMI is a generic, MBD is a specific SolidWorks solution. Any questions?
So really the only time saver would be downstream. We're still creating, putting in the effort to create essentially a 2D output, whether PDF or paper drawing, right?
So yeah, so the question is, if we're still doing a 2D drawing, is there any point to using MBD or DimExpert, right? I'd say the only real time-saving benefit would be in spots where utilizing the automatic dimensioning is saving you time. So in this example, if I'm going to delete the existing DimExpert scheme on this thing, I'm going to do DimExpert scheme, I'm going to do geometric tolerancing, and I'm going to say these are my datums, and I want to just get everything. If you get this really humming to the point where you're able to predict what's going to happen when you do that, I can see that being a nice time saver also. Now it's also generated the annotation views. So now if I go to File, Make Drawing from Part, and I pick the annotation views from over here, and I say import annotations and use DimExpert annotations, this could potentially be a time saver also, because now all these dimensions are there for you and geometric tolerance in the drawing ready to go.
There was just an option there for design annotations, not the other kind of dimension I was referring to.
Yes. Yep.
Can I pull in all feature tree dimensions?
So what that'll do, yeah, so it's a great question. And now that you understand how when SolidWorks DimExpert creates these annotations, it automatically assigns the annotations to what's called an annotation view. And these annotation views control the hide show state of the dimensions, right? The same thing happens with your regular SolidWorks feature dimensions, or can happen. So if I go back to the SolidWorks feature tree here, and I say annotations, show feature dimensions, there's all the feature dimensions, right? And I go through here and I hide these annotation views, and I start showing these annotation views again. You can see that SolidWorks has also taken this 16 sketch dimension, which is to the counterbores up top here, and it has assigned this dimension from that sketch to the top annotation view. So before DimExpert, annotation views were actually there before DimExpert was there. And you could potentially do the same thing where you're setting up yourself in model mode. You're setting up yourself to be ready to go right into drawing mode. You can predict where all the dimensions are going to land. You can predict what dimensions are going to land on what views.
Yeah, and you can hide a dimension here.
I don't know if you can hide it. I think what you have to do is you have to say select annotation view and then move it to unassigned items, and then you would hide the unassigned items.
You can also say, you can deselect mark for drawing.
Yeah, you could do. That's good.
It's in your right.
Yeah. So if you go to don't mark for drawing, it becomes purple, and then it won't show up when you go to add this to a drawing.
That's actually kind of fun.
Okay. Yeah.
I'm still curious what happens if you try to delete it.
Oh, yeah. Good idea.
I mean, it's kind of.
So it's none of the selected entities could be deleted.
It doesn't really make sense.
It's because you're not in the right mode. You know, like you have to be in sketch mode to modify a sketch.
Yeah, it's not that I wanted to delete this dimension. I wanted to delete the showing the dimension I wanted to do any parts of the drawing.
Yeah.
So you
Yeah. I would say either do the mark for drawing, or like I said, the other way that you could do it would be move it to the unassigned items view, and that way, you know, it'll hide when you hide this view.
I hate to keep beating on this, but when you're in the drawing, is there a way to show design annotations rather than import them?
Yeah. You use what's called import model items. So if I take these guys here and delete them, and I take these guys here and delete them, what import model items does is or insert model items, it lets you select from this tree here anything that exists in the model that you want to bring into the drawing. And the most common one is various forms of dimensions and pattern information. Less common annotations, so you can put annotations in the model and bring them right into the drawing so that they're still driven by the model. And then even less common than that is like bringing in planes or axes from the model. So if we go here to insert model items, I'm going to say driving model dimensions that are marked for drawing. There's also not marked for drawing. And then whole wizard locations, the center point of my whole wizard holes, and maybe my whole callouts also. And then I'll say I want to bring them in from the entire model, and I want them to land in all drawing views, and I hit the green check mark. And now these are driving dimensions, which means that if we change this dimension, it's going to actually change the model. The DimExpert dimensions are driven. They're not going to do that. But these are actual driving dimensions coming from the model.
That's good.
So can you import model dimensions into? That'll save a lot of
I
time.
think he jotted something down in his notebook.
Yeah, I think I want to find out that answer for you, but I'm definitely game to try it here. So I assume it would be a very similar workflow. Yep, my pleasure. Nice meeting you, Mark. So we would go here to top. We would go to orient, and then we would go to capture 3D view, and then call it top. And then I'll go to right, activate and reorient, and then we'll go capture 3D view, and that should be enough just for this test. And then I'm going to go to 3D PDF. We'll do single sheet. Yeah, cool.
That would be
So then you would just put in all your tolerancing on these dimensions. Yeah. Let's see what the 3D PDF looks like. I mean, the step file looks like if we do that.
Is that
Yeah, I'm curious. Let's see. Okay, let me try this test a different way. I'm going to go back to SolidWorks and I'm going to do output 3D PDF. No, output step 242. Because when you open a file with PMI in it, there's actually a check mark to include the PMI. And since I just opened it right from the PDF, I don't know if that check mark was taken. So let's take this one. Yeah. I mean, that's what the machinist would say. So I guess the only question is, will that, oh, and this is why I wrote down my notebook, because when you do the actual, PMI using DimExpert, the part of the DimExpert tree, when you create a DimExpert location dimension or a size dimension, is that it analyzes the topology of the geometry selected. So it recognizes this is a face, that's a face. This dimension is connecting those two faces. So since the driving dimensions are coming from the sketch, you're not going to get that same intelligence. It's like, this is a dimension from something theoretic, like a previously existing sketch line, to something theoretic, a previously existing sketch point. So will it still be able to be utilized by downstream machining operations if it doesn't see those faces? That's what I need to find out.
Yeah,
So-
because you could do like 80% of your work right up front in the model, and then just add a few other dimensions and tolerances.
That was the cool thing about annotation views. When I did that webinar for that company, it was probably a couple of years where I was using those annotation views a lot because I was setting myself up for drawings. Then when I make a drawing, it was just like everything landed right where I wanted it. It was good to go. Supported section views, so you could really do a lot with that in the model. And then also, if you ever want to recreate the drawing, or if you lose the drawing, like the drawing is corrupted or anything, everything's in the par file. So it was really nice. So yeah, I totally get where you're coming from on that. And I'll find out for you if that will actually carry through to the downstream stuff. Cool. All right, any other questions? I'm not trying to rush you, but I don't want to hold you any longer than 3. I can stay all day though if you want, I love being in California. All right, well, if you do think of anything else, you know how to get in touch with me. Of course, I want to say thank you so much for having me in today. I hope that you picked up some good tips and tricks, and we'll do this again sometime soon. Come back out here, maybe like if it starts getting cold in Pennsylvania and it starts getting warm and not rainy here, I'll be back out. Yeah. All right, well then I think it's going to do it. But I think you're going to give me a short tour, right? So cool. All right, well, I'm going to shut everything down. And Rudy, I think we're good to go. Thank you so much for hosting. And thanks to everybody who's online. And if you guys have any questions, feel free to reach out to me. I'm always happy to help. The end.